Hey guys, you are welcome to my study with me session for preparation for the examination tomorrow, which is pharmaceutical inorganic chemistry. And I'm going to be taking some questions and actually providing solutions to them. Most of these questions were questions that I extracted out during my study session and not previous past questions. Although some of them coincided, English. Some of them coincidentally are the past questions for previous years, but most of them are just extracts from my own personal study. So take your pen and your book and paper and then ride with me on this journey. Now, the question one says a greater percentage of pharmaceutical and medicinal agents are a greater percentage of pharmaceutical and medicinal agents are. Now, the correct answer is organic. They are organic compounds, okay? A greater percentage of pharmaceutical and medicinal agents are organic compounds. Now, we also have some inorganic compounds that are used. But when they say greater percentage, it means out of 50%, let's say out of 100%, about 80% are organic, and then we also have 20% that are what? Inorganic. So a greater percentage of them are organic compound. Now, the second question under this, it says the use of inorganic compound as pharmaceutical agent is enhanced by understanding of their interaction with. The correct answer is biological system. The use of inorganic compound as pharmaceutical agent is enhanced by the understanding of their interaction with biological system. And that is the reason why we are studying what we are studying, okay? Pharmacy. To study the interaction of these drugs with the biological system. If you understand their interaction with the biological system, then it will be very easy for us to use inorganic compounds as pharmaceutical agents or as pharmaceutical agents, okay? So, let us continue. Next one says, outline the different classes of inorganic substance as pharmaceutical agents. Now, I'm trying to answer these questions based on understanding and not looking at any book. Let me see if I can actually get most of them. I said them myself about 2 days ago. So let me see if I can get them, like I can record them. Now, say outline the different classes of inorganic substances as pharmaceutical agents. Now, I believe this one we have the first one, inorganic ions. You don't take substances, you say inorganic, the first one here, inorganic ions as body electrolyte. Inorganic ions as body electrolyte. That's the first one. Number 2, inorganic compound as GIT drugs, which is gastrointestinal drug. Then we have inorganic compounds in dentistry. Then we have inorganic compounds as complementary agents. Inorganic compound as complementary agents. Then we have inorganic compound used as body electrolyte. Then finally, I think we have miscellaneous use. How do they spell miscellaneous the other time? Let me just spell it. I'll look at the correction later. Miscellaneous use of inorganic compound. Miscellaneous use of inorganic compounds. Is there any other one I'm forgetting? Is there any other one I'm forgetting? Let me see if I'm correct or not. Miscellaneous use of inorganic compound. Let me see if I'm correct. We have inorganic ion, okay. Inorganic compound and GIT drugs. I'm correct with those two. Inorganic substance as, okay, I didn't write as pharmaceutical aid. As pharmaceutical aid. So that's the one I missed. Inorganic, and funny enough, it came to my mind though, but I was just busy writing the other ones and I forgot it. So the one I missed, I'm going to write it with a yellow pen to indicate that I didn't get that one correctly. So we have inorganic compounds as pharmaceutical aids. Okay, we have inorganic compounds as pharmaceutical aids. Now we are going to give an example of each of these as time progresses. Number 2, the human body is comprised of dash and dash fluid compartments. Of course, we know the human body is comprised of the extracellular and intracellular fluid compartments. So the correct answer is what? Extracellular and intracellular. Now the B part of it says these components are separated by a, what is the correct answer? Cell membrane. The extracellular fluid compartment and the intracellular fluid compartment are separated by cell membrane. Now number 3, the semi-permeable membrane is not freely permeable to water. The semi-permeable membrane is not freely permeable to water. Is that true or not? Let's think together. Now the semi-permeable membrane, it allows the inflow of substances and also does not allow the inflow of some substances. But the question is it freely permeable? Does it allow all water to pass through? True or false? So let's look at the one that you think is correct. Is it true that it's not freely permeable, or false that it is freely permeable? Now the correct answer is what? False. Because the semi-permeable membrane is freely permeable to water. So this note here makes it what? False. So the correct answer is what? False. Are we getting it? Now the next one is electrolyte may be required either for. Now why do we need electrolytes in the body? Why do we need electrolytes in the body? Now electrolytes are required either for correction, or we can start with replacement. They are required either for replacement or correction of acid-base balance. They are required either for replacement or what? Or correction of acid-base balance. Okay, that is what electrolytes are needed for. They are needed for replacement or correction of acid-base balance. Okay, now let's look at the next question. The predominant anion in the extracellular fluid compartment is. The predominant anion, the correct answer is the chloride ion. The chloride ion is the predominant anion in the extracellular fluid compartment. Now, please make sure that you must have read through the material. This is just like trying to recall everything that you've read. I'll make sure that I do it for every of the other parts of this course, so that it will just be like a revision guide for everyone participating in this study with this session. So the next one is dash ion is responsible for maintenance of osmotic balance. The chloride ion is the one that is responsible for maintenance of osmotic balance. One that is responsible for maintenance of osmotic balance is the chloride ion. Now, the predominant anion in the intracellular fluid are dash, and they are administered as dash. This one seems seems complicated. Anyway, let me think. The predominant anion in the intracellular fluids are the phosphate ion. Okay, phosphate, which you can take as HPO4 minus, or you can write it as phosphate ion. Okay, you can write it as the phosphate ion. Now, the predominant anion in the intracellular fluid compartment is the phosphate. Why that in the extracellular? Please take note, extracellular means outside, intra, inside. Are we getting it? Intracellular fluid compartment needs the phosphate ion. Why the extracellular means what? The chloride ion. And you must take note of this anion. Now, the word anion means what? Negatively charged ions. Okay? It means negatively charged ions. So we can say that all the ones we've been talking about here are negatively charged because we have the cations and the anions. So you don't model up the whole something. Are we getting it now? Now, the chloride ion is responsible for maintenance of osmotic balance. Now, the predominant anion in the intracellular fluids are the phosphate ion, and they are administered as phosphate salts. They are administered as phosphate salt. Okay, now let's take the next. The second most predominant, or most prevalent rather, the second most prevalent anion in the extracellular fluid compartment is, which of them is the second most prevalent anion? Okay, we have the bicarbonate ion. Can write it, the bicarbonate ion is the answer. Now, formula is this: bicarbonate ion, and together with, now the bicarbonate ion together with carbonic acid function as the body most important buffer. Functions as the body most important buffer. Now, what does buffer do? Buffer is a mixture of a weak acid and its conjugate base, or the salt of that acid, that tends to resist the change in pH of the body. Now, the physiological pH for the human body is 7.4. So the bicarbonate buffer and the carbonic acid helps to absorb an excess of an acid or excess of a base to maintain the pH at 7.4, so that there won't be an increase and there won't be a decrease. So that is that. So the second most prevalent anion in the extracellular fluid compartment is the bicarbonate ion, and it works together with. So the predominant means of transport for CO2 from tissue to lung is also bicarbonate. The bicarbonate ion, which is HCO3 minus, or you can call it hydrogen triazocarbonate. Okay, sorry about that. You can call it the hydrogen triazocarbonate ion. So that is for that. Let's look at the next. The major cation in the extracellular fluid compartment is sodium. Sodium ion is the major cation in the extracellular fluid compartment. So you notice something, that we are done with the intracellular fluid compartment now. We are coming to the we are done with anions now. We are coming to what? Cations, both in the intracellular fluid and in the extracellular fluids rather. Now, the major cation in the extracellular fluid compartment is sodium ion, and it is responsible for For hydration, responsible for hydration and osmotic pressure. Osmotic pressure. Responsible for hydration and osmotic pressure. Now, the major cation found in the intracellular fluid compartment is, where's the major cation found in the intracellular fluid compartment? That should be the potassium. Potassium cation or potassium ion. Can take it as K+. Okay, so for intracellular fluid, you have the potassium ion, while for the extracellular fluid, you have what? The sodium ion. Okay, now, which of the following is not true of sodium cation? A, it is the major cation in extracellular fluid. This is true. Now, B, it can be used in sodium replacement therapy. This is true. C, it can be administered orally and not intravenously. And D, it is responsible for hydration and maintenance of osmotic pressure. I've said before that it is responsible for hydration and maintenance of what? Osmotic pressure, which is what we have here. For hydration, and so we come back here and put maintenance, expo, and maintenance of osmotic pressure. So we come here, and so automatically we know that option C is wrong, and we are looking for the wrong one because they say which of the following is not true. So the wrong one automatically becomes the right answer. Why? Say it can be administered orally and not intravenously. It can be administered orally and intravenously. Now, when you say something is administered orally, what does it mean? Means you give it maybe as a drug to swallow, or let's say as a syrup to take in to the through the mouth. Are we getting it? Why intravenously is what? Like an injection through the vein. Are we getting it now? So the sodium cation can be administered either orally and what? Intravenously, and not intravenously. You can take it in either orally or intravenously. So this note here negates intravenously, whereas intravenously is one of the routes through which it can be administered. Okay, so it makes option C the correct answer. So we say correct answer is what? Option C is our correct answer. Now let's look at the next. Which of the following is not true about potassium ion? Which of the following is not true about potassium ion? The salt for potassium replacement therapy is KCl. Is that true? Is that true? Yeah, that is true. It is essential for growth, normal cell function, metabolism, as well as cardiac function. This is true. It can be administered orally as Ringer solution or as potassium gluconate elixir. It can be administered orally as enteric coated tablet. Now, this Ringer solution is something that should be taken in intravenously. Are we getting it? Maybe through injection, Ringer solution. So the correct answer to this question is option C2. Why? Because they said it can be administered orally as Ringer solution. No, it can be administered orally as enteric coated tablets. Are we getting it? As enteric, a tablet that is coated, enteric coated tablets, and not as Ringer solution. Ringer solution is what? Intravenously. So had it been you had this, it can be administered intravenously. If here were to be intravenously, then this option would have been correct. So it can be administered orally as Ringer solution is what? Is the wrong answer, and that is the correct choice because we are looking at the one that is what? True. So we can say correct answer is what? Option C. Now let's look at the next. The next is an equation. Now the question says ammonium chloride is used for the production of cough syrup. An unknown amount S gram of the salt was treated with silver nitrate to give a yellow precipitate. After dry to constant weight, 0.5 gram was obtained. Write the equation of reaction. Now, the equation of reaction for this is You have ammonium chloride, aqueous, plus silver nitrate, aqueous. Now, when these react, what do you think you are going to have? Now, this ammonium chloride is going to break to form the ammonium ion and what? Chloride ion. Silver will form silver ion and what? Nitrate ion. So the positive ion of this will combine with the positive ion of this. So we are going to have something like this. This positive combine with this positive, and this will combine with this. And then finally, you are going to have NH4, or let me write the major product first that is of interest. We have Ag, which is this Ag, then Cl we combine, plus NH4, and then we have NO3. So this is the product of the reaction. Now this is a solid and this is aqueous. Now this solid we precipitate out. So in some cases, if you want to indicate a precipitate, what do? You use this to indicate that it's a precipitate, or you can write it out even as precipitate. So this is the equation of reaction. If you write this, you get certain amount of marks. Now the next one says calculate the amount of sodium chloride of ammonium chloride that was assayed. Now, for us to calculate the amount of ammonium chloride that was assayed, let us go to a fresh sheet, and then, or first of all, let us just calculate. Let's go to a fresh sheet. You have the equation of reaction as ammonium chloride plus silver nitrate to give us silver chloride plus ammonium nitrate. Now, what is the mass of ammonium chloride that reacted? Because our major concern now is between ammonium chloride and what? Silver chloride. Because silver chloride is the precipitate, and the mass of the precipitate was given. They say after dry to constant weight, 0.5 gram was obtained for the precipitate. So it means that the amount of silver chloride at the end of the reaction, the amount of silver chloride is what? 0.5 gram. Now, if the amount of silver chloride is 0.5 gram, it means that of ammonium chloride is what you are looking for. That means the starting material you don't know. Are we getting it? But we know from molar ratios, from mole ratios, we know that 1 mole of ammonium chloride gave how many moles? Gave 1 mole of silver chloride. Now, what is 1 mole of ammonium chloride? We need to calculate the molar mass of ammonium chloride. Ammonium chloride would be equal to, what is nitrogen? Molar mass of nitrogen, atomic mass rather, is 14. Hydrogen is 1. 1 times 4 is 4. Chlorine is what? 35.5. Now, if you punch this in your calculator, I believe you are going to have 53.5 gram per mole. So the molar mass of ammonium chloride is 53.5 gram per mole. Now, what is the molar mass of silver chloride? The molar mass of silver chloride is equal to, now the atomic mass of silver is 107.8. So we say 107.8 plus 35.5. Why do we have to do it like this? We know that molar mass is the sum of all the atomic mass. So if you sum these two together, you are going to have a value, and that value will be the value for the amount or for the molar mass of silver chloride. So when you sum this together, it's giving us 143.3 gram per mole. Now you are now going to come here and say 1 mole of this gave 1 mole of silver chloride. Therefore, 1 mole has a mass of what? 143.3 gram. So So we now say 143.3 gram of ammonium chloride is equal to, we have here, sorry, not ammonium chloride. Ammonium chloride is 53.5. So you say 53.5 gram of ammonium chloride we give 143.3 gram of silver chloride. Therefore, now the amount of silver chloride from the experiment was given. That was the amount precipitated out. So we now say 0.5 gram of silver chloride would be equal to what? X. At this point in time, this multiplied by this is what? 143.3 times X is equal to 53.5 times 0.5 gram of what? Ammonium chloride. So your X will be 53.5 times 0.5 divided by 143.3 gram, all in gram, of ammonium chloride. When you punch this in your calculator, what are you going to have? 53.5 times 0.5, which is 26.75, divided by 143.3. X would be equal to 0.187 gram of ammonium chloride. So the yield, or the mass of ammonium chloride that reacted to give 0.5 gram of silver chloride is 0.187 gram of ammonium chloride. Now, the next question says, what is the amount of chlorine present in ammonium chloride salt? What is the amount of chlorine present in ammonium chloride salt? Now, to solve this, you are now going to say the amount of ammonium chloride, total amount of ammonium chloride is what? This is equal to 0.187 gram. Okay, I think that's what we calculated for just now. Now, in ammonium chloride, what is the proportion of chlorine in ammonium chloride? Is about 35.5. Total mass of ammonium chloride is what? 53.5 gram. That of chlorine ion is what? 35.5 gram. So you are now going to say amount of ammonium chloride, amount of chlorine in ammonium chloride would be equal to 35.5 gram divided by 53.5 gram times the total mass. Total mass given is what? Or calculated is what? 0.187 gram. If you punch this in your calculator, what are you going to have? Now you are going to have, let's say, 35.5 divided by 53.5, which is 0.6635 times 0.187 times 0.187, which is 0.124 gram of chlorine is present, or the chloride ion is present in 0.187 gram of ammonium chloride. And that is the solution to that question. Now, in some cases, in the exam condition, you may be given the same question, and then you may be asked to calculate the percentage of chlorine present. Now, for you to be able to calculate the percentage of chlorine present, you must be able to know the percentage, the initial that reacted, and what? The final. But since that was not given to us, we are going to end it here. Thank you for your time. So, We'll bring other questions and we'll solve other questions. Maybe you should just go through these ones all over again. Thank you for your time. And make sure you subscribe to my channel. Ciao, ciao.